Greetings everyone, today we are going to build a timer using ATmega 8 microcontroller. The format of the display is shown here. We will show and count seconds and milliseconds. For this, timer 2, which is an 8-bit timer, will be used. We will use 8 MHz as the clock frequency of the microcontroller. Our idea is to count each millisecond with one timer 2 cycle. We will use timer 2 with CTC mode where TCNT2 will be refreshed with each compare match. With 8 MHz speed, each machine cycle will take 0.125 microsecond. With prescaler of 256 of timer 2, each tick would take 32 microseconds. So for 1 millisecond, that is 1000 microseconds, we will need around 32 timer ticks. So we will start with putting 0 to the TCNT2 register. And the value of 1F, which is 31, is put in OCR2 register, because the next cycle after compare match will make TCNT2 0. Hence total 32 ticks are achieved. For controlling timer 2, TCCR register is used. First 3 bits CS20 to CS22 are used to set the prescaler. As we will use 256 as the prescaler, we will put 110 to these 3 bits. Then for the waveform generation mode, WGM21 and WGM20 is used. For CTC mode of timer 2, we will put 1 and 0 in these 2 bits. Rest of the bits in this register is 0. To enable the compare match interrupt, we need to make OCIE2 bit of TIMSK register 1. We will use ATmega 8 as the microcontroller, and for the output we will use 1602 standard LCD display. RS, RW and E pins of the LCD will be connected to port B 1, 2, 3 pins respectively. The data pins will be connected to port D. For controlling the timer, first button is connected to port B pin 0 and a buzzer is connected to port D pin 2 to indicate the counting is finished. All the buttons will be pulled up internally, so the pins will be normally high and low if pressed. The next button is decrement 5 seconds and the last one is increment 5 seconds. Next, let's get into coding the chip. So we have created a project with Microchip Studio and selected ATmega 8 as the microcontroller. Here I am using lcdlib.h and timer.h header files. These files will be linked in the description box. So primarily we will define these 4 functions. So first we are declaring the input and output pins. There are 3 input pins for the buttons and they are being pulled up, and for the buzzer, port D pin 2 is declared as an output pin. Next we are initializing the LCD. To display the format, we are putting these strings into their specific places. For interrupt, a callback function is assigned. What this function does is, so this function will be called internally after each compare match. That means after each millisecond, this function will be executed. First, if the second is not 0, then the millisecond will be checked. Then if the millisecond is 0, then second will be deducted 1 and millisecond will be 999. And if millisecond is not 0 and if second is 0 and millisecond is also 0, timer flag will be assigned with 2. That means the timer has finished counting. If millisecond is not 0, then millisecond will be deducted. Next, we are setting the timer 2 with CTC mode. Next, we are enabling the compare interrupt of timer 2. These functions will be found in the timer.c file. I have created a static library for timer and linked the library to the executable project. Next, we are setting TCNT2 register with 0 and OCR2 with 31. Next, these 3 functions will be called in the while loop. Let's get into these functions. So first, we will handle inputs. We will check if any one of the buttons is pressed. So the first one is the PB6 button. If this button is pressed and second is greater than 5, then second will be deducted by 5. The next one is PB7, which will increment the second value if the second is less than 55. These delays are used to handle the button debouncing. The next one is the start or stop button. First, if the timer flag is 0 and this button is pressed, that means it tells the microcontroller to start the timer. So the timer is being started with the prescaler of 256 and the timer flag is 1. And else, that means the timer is running or it has been stopped. If the button is pressed, then the timer will be stopped and the timer flag will be 0. In each iteration of the while loop, we will update the display. Here, seconds, unit and decimal value is being extracted and converted into characters. Same is done for the millisecond. Unit, decimal and hundredth values are being extracted and made into characters. Then for the final display, a string is being created with seconds and milliseconds values. And finally, it's being displayed in the LCD. So the final function is handle status and it will check if the timer has finished counting. If it does, then the buzzer is turned on and else the buzzer is turned off. Next, we will build the project. And we will load the hex file into the Extreme Burner software. Next, we will write the ATmega 8 chip. Next, let's look into the output. The source code for this project will be linked in the description box. If you like this video and would like to watch similar contents in the future, please give a thumbs up. Thank you.